Hello, everyone. Uh, Good afternoon. Dear authors and invited guests, welcome to Technical Session 12F. Myself, Harsh Soni, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held on 17th of July in Goa, India. The virtual event is being held through Zoom from 17th to 19th July 2025. And this session will be the last session of this conference. I hope you will enjoy the knowledgeable and interactive session. In this session, we have total 11 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. So on 8 minutes, I will raise a gentle reminder so that you can conclude your presentation on time. There is another request to all the participants that you may all please stay connected with us till the closing remarks because there are some instructions that we have to give to all the participants. Further, if you have any query or any update, you can directly write it to me in the chat box. Just before we start the session, I'd like to introduce you all to the chair for the session. Just a second. Dr. Tatwadarshi Nagarhali. Dr. Tatwadarshi is the Associate Professor and Head Department of Artificial Intelligence and Data Science, Vidyavardhini's College of Engineering and Technology, Maharashtra. With extensive academic experience, his expertise spans machine learning, deep learning, and natural language processing. He has authored over 50 research papers at both national and international levels. Dr. Nagarli is keen in collaborative research in areas including data science, natural language processing, deep learning, AI, and data security. Welcome, sir.
Yeah, thank you. Thank you, Ash.
Yes. So without wasting time, I'll start the first presentation. Just a second. So our first presenter is Piyali Karmakar, and she's going to present on a bidirectional picture exchange communication system for persons with CCN.
Hello, sir.
Your author,
Am I
you may
audible?
please proceed with your presentation.
Yes, sir. Sir, is my screen is visible?
Yes, it is visible.
Good afternoon, sir. Good afternoon, everyone. I am Piyali Karmakar from IIT Kharagpur. Today, I am going to present my research work entitled as a bidirectional picture exchange communication system for persons with CCN. Here are the outline of my
Your
research.
voice is not very clear, actually. If you can,
Hello.
yeah, your voice, I'm not able to hear it properly. Harsh, are you able to?
Sir, I think that there's a background noise she has.
Hello, sir. Is it
Yeah,
okay now?
now it's, yes, yes, yes. Please proceed.
Okay, okay. Okay, sir. Okay, sir. Here are the outline of my today's presentation: introduction, key idea, proposed methodology, results and discussion, multilingual adoption, and finally conclusion. I'll begin this presentation by providing a brief introduction and motivation behind this work. Well, communication is the birthright of every human being. However, active persons with complex communication need often face barriers in accessing the outside world due to several speech and motor impairments through nonverbal communication. In this case, augmentative alternative communication method is an alternative system of communication that assists them not only in communication but also in various other aspects of life, including education, sports, etc. A type of such AC system relies in picture-based representation where no traditional sentence structure is needed to convey the context. This type of communication system is called picture exchange communication system. Bliss symbols and pictograms are two major components of this communication system, where pictograms represent the whole data in the form of images and icons, where no grammatical rules are needed to convey the text. Similarly, Bliss symbols uses shapes and digits. It also has some indicator symbols like person indicators, family indicator relationship, etc. These both bliss symbols and pictograms are used in non-verbal communication. So the persons with cerebral palsy, especially with complex communication need, typically rely on this communication system. Now I'm going into the heart of my research work. So the key idea is to create a translation system for symbolic to natural language text translation. We started our work by creating a symbolic to English dataset where it has the series of symbolic sentences and their respective English sentence. Then we created a translation module that translate the symbolic sentence into grammatically correct English sentence. And finally, we adapt an Indian language Bengali to facilitate the communication in Indian language, especially for the persons with Bengali users. So in this slide, I have given the workflow of the first task, that is symbolic to English dataset generation. We started our work by creating a graphical symbolic corpus. This corpus includes bliss symbols and pictograms along with their respective English tokens with a unique numeric ID. Then we added some special features like pictogen module. This module is needed to deal the unknown text like unknown English words and represent its corresponding pictogram. This is how we created the graphical symbolic corpus, and then using this corpus we created an English to symbolic data set, and finally reversing the data we get symbolic to English data. In my later slides I have explained all these steps in detail. So starting with graphical symbolic corpus, the first two images show bliss symbols with their respective ID called bliss ID. The last two images show the pictograms where you can see each of the pictogram are assigned with a unique ID prefixed by English letter P. Now we also had added some cultural information into the dataset because in the diversity country like India, the communication should reflect the local language or regional language. So for that, we used a data set collected from Indian Institute of Cerebral Palsy, which is the IICP data set. So these pictograms are not only familiar and meaningful for the Indian users, but also it helps to understand easily for the persons with cerebral palsy. Here two words like Tanpura and Fuchkawala, these two words are collected from the IICP dataset. We also added some semantic attribute informations like tense type information, type of statements like questionnaire explanation. So here two images shows the output. We also added the numeric and temporal information like the month, January, numbers, etc. However, the corpus sometimes encountered with unknown and uncommon words. To deal them, we used a novel module called Pictogen. This module is basically an open source web-based application that accepts the English tokens as the input and predicts the most probable pictogram for the given input text. So here two words like woof and stack. These two are predicted using the Pictogen model. So where you can see this word also assigned with a numeric ID prefixed by English letter I. So this is how the graphical corpus is created. Now, using this corpus, we created the English to symbolic dataset, where we taken the English sentences from the English conversational dataset. We tokenize the English sentence, and each of these English token will be mapped with their respective graphical symbols from the graphical corpus along with the respective numeric ID. So here we can see the English sentences and their respective symbolic sentences. And this image shows the user interface of the dataset. Now we simply reverse this data to get symbolic to English dataset. This dataset is basically the input for the translation dataset. So the we have the series of symbolic sentence and their respective English sentence. This is the input for the translation model. The dataset looks like this. Now to execute the translation task, we structured A attention-based encoder-decoder transformer model that takes input as the series of symbolic characters and outputs its respective grammatically correct English sentence. And this image shows the user interface of the translation. Here we can see the model generated output in this page. So coming to the results and discussion, we can say that our data set is diverse in various dimensions like age group, gender, type of language like Indian English, UK English, etc. We also extended our model into the Indian language Bengali because we tried to help this model and reach this model to the Indian user so that they can learn the symbolic context in their own
Sorry
language
to
like
interrupt,
Bengali.
Sophia, but you
Yes,
have last 1 minute for the presentation.
yes, sir. Yes, sir. Sure, sir. So here, as there is very less amount of Bengali words whose respective graphical symbols are present. So for that, we use a pipeline like Bengali to English and English to symbolic. So here is the pipeline where we translated Bengali to English, then English to symbolic. So we get Bengali to symbolic, and this dataset is used for the Bengali to symbolic translation. Here also we used a pretend transformer model. So the input will be Moi Arohan and output will be a series of symbolic characters like this. This table shows the original Bengali text, the translated text, and finally the symbolic output. Here are the user interface of the symbolic to Bengali to symbolic translation. So, in concluding my presentation, I want to mention that we designed a model for the individuals with several impairments, focusing on persons with complex communication need, especially persons with cerebral palsy. This model enables English to symbolic and reverse translation using the curated dataset. The Pictogen module is needed to deal the unknown text to improve the dataset reliability. Also, this dataset incorporated the tense type information, numeric and temporal information to make the dataset more expressive. We extended the our task into Indian language like Bengali. However, there is a need to validate the symbols and pictograms that are used in our model by the domain experts to maintain the standard of ASC compliances. We are in the process of creating a graphical user interface for the end users so that they can use this model, they can provide some feedback. Based on their feedback, we will modify our system. So our target is to improve the effectiveness and usability of our model for the real world context. Thank you.
Yeah, great work. So your
Thank you.
your research is basically with regards to the generation of the data set, if I'm not mistaken.
Yes, sir. Yes, sir.
And for the date, you said you have created symbolic database for Indian this thing, right?
Institute of Cerebral Palsy. Yes, sir.
Okay. And so this is you have done this project for them or in collaboration or something?
Yes, sir. Currently, we are not collaborating. We are just requested them to provide some data set, and we are also in the contract that we will, after creating this model, we will visit their institution like Indian Institute of Cerebral Palsy, Kolkata. We will visit their
Okay.
institution, and we can meet their the students, our model, and based on their
Okay.
feedback, we will modify our system.
Okay. Great, great. So for the Indian words that you have included pictures as well, right?
Yes,
So
sir.
these
Yes.
pictures, where have you taken these pictures from?
So these Indian pictures are taken from the ICP database.
Okay, from their database itself.
Yes, sir.
So this is already prevalently being used, right?
Yes, sir. Yes,
Those
sir.
those symbols, Indian symbols.
Yes, sir.
Okay, okay. Yeah, good work.
Thank you, sir. Thank you so much, sir.
Thank you, dear presenter, for this wonderful presentation. Now, I'd like to invite the next presenter. Next, we have Pallavi Patil, and she's going to present on comprehensive analysis of fundamental parameter regulating malware detection performance.
Good
Dear
afternoon,
author,
all
you
of
may,
you.
yes, you may please proceed.
Uh, is my screen visible?
Yes, it is visible. Please go ahead.
Okay. Good afternoon, session chair, all the attendees and researcher and the meeting. Myself, Pallavi Patil, along with my co-author, Dr. Mansingh Rathod sir, I'm going to present a comprehensive analysis on finding the fundamental parameters which are regulating the malware detection performance, which is again a review paper under my title of research work. So we are going deep dive into the following outlines, that is proposed research topic introduction, literature survey, research scope from literature, methodology, on particularly on malware. So we must know that what are the different types of a malware. So here some different types of malware are enlisted like rootkit, botnet, viruses, ransomware, and their attacking technology is attacking pattern is mentioned. Like if we consider the malware encrypts the data, and if we consider the botnet that infects the devices. So there are some malware types are mentioned which are working or attack on particular way, which is mentioned in this slide. Moving toward that different methods which are there to detect the malware considering the existing literature, that signature based detection method is one of their, anomaly based detection method is there, heuristic based static analysis, dynamic analysis, hybrid analysis, deep learning based, along with the AI-based detection method, and encrypted traffic and behavioral detection methods are there. So in signature-based, existing signature patterns are there. According to that, then malware is identified, and in anomaly-based, drastic changes in a behavior through which that is identified. Like if we consider that in a dynamic, so in dynamic, it uncovers the vulnerabilities which are not currently presenting. So we are focusing on the combination of all different patterns to find the different malware detection method. So moving toward that we must know the how are the different ways to contaminated your system or your network by the malware. That some of the patterns or some of the methods are insecure patch management are there, or untrusted applications are the untrusted applications are there, some of the mail attachments are there, some of the phishing mails are there, etc. These are the different types of methods which may get contaminated to your system. Then this is my literature review. In that, I segregated the papers depending on their data set or depending on the particular system. First one is that Android malware detection I have segregated, where they have particularly focusing on the Android malware where the system get contaminated. Then second is in the network traffic, malware detection in network traffic, and third one is the malware detection in the system. So they use different data set and different techniques, methods are used, that is machine learning and deep learning methods are used. And again, I have segregated another literature survey that contains the pattern or that contains the malware detection basis on the particular data set. And specifically, if we observe here, the mostly CNN, LSTM, and RNN are used for finding out the for detecting the malware. But if we observe that detecting the malware, if we consider the overview of malware detection, so we segregated that Android, network, and system. So on that, considering literature survey, machine learning, deep learning methods are used, different data set they are using, and different research gap, like need to find the cross platform detection, finding the zero-day malware detection if that malware signature or if any unnoticed vulnerability is there, and that may be loophole for the malware. Then handling diverse network data and adversing rapid malware detection. So we have to focus on that kind of a thing. For focusing on that, we just segregated the priority level, that if we consider the signature based and behavior based, than feature selection, like for static and dynamic and real-time detection. So by considering all these things, the highest priority goes toward for polymorphic fileless malware, which mutate their behavior after each after each transaction or after each changing behavior. So considering this, the systematic literature review process for malware detection is that I have find out some different papers, some different articles, and their objectives, what exactly the objectives are there. There are particular criteria to find out that different particular malware, if they're finding out quantitative base or qualitative base, that are segregated. Then if we consider the different features which are mentioned in the existing literature surveys, for particularly static malware detections, they are used the file headers, byte sequence, file metadata string, control flow graphs, and upcodes are mentioned over there, which are providing the file characteristic, potential risk, or finding the suspicious keywords which are there in a URL, or illustrate some program execution flow of abnormal behavior, which is considered in static malware detection. The next we consider if the dynamic feature which are considered in the existing paper, their API calls, system calls are there, memory uses, network traffic, and behaviors. All these things are used in the existing literature survey. So with respect to the network, again, the flow features are there, then DNS request patterns are there, HTTP features are also there. So analyzing the packet and flowing duration can be identified in the malicious that something malicious activity is happening or some malicious packets are there in that. But considering all these things, again, this is again malware detection features which are considered for network, that flow patterns are there. So these some features which they are used, but analyzing
Sorry to
all these
interrupt you,
things.
ma'am, but you have last
Yeah.
1 minute. Kindly
Okay.
conclude it.
Okay. Analyzing these things, that according to this, I analysis that for finding the malware or detecting the malware, we must have the combination of upcode sequence, API calls, network traffic patterns, and system behaviors, which may robust or which may get help to detect the malware. Because if we consider the opcode sequence, though if we consider the metamorphic and polymorphic malware, it may get offuse the code but can't completely change that opcode semantics which are used. So by considering that semantics, we can analyze that there is a fileless malware or metamorphic malware is present. So considering all these things, the conclusion is that if we use the enhanced machine learning, deep learning technique to detect that particular thing along with these features, may get easily find out the malware which are not easily detectable. That is, if we consider the polymorphic, metamorphic, or fileless malware or opcode malware, which are causing the upfusion or not detecting pattern, and latest systems or latest frameworks which are used for malware detection. So these are some papers which I go through for you consider making this presentation. Thank you. If any question or queries are there.
Yeah, so yeah, good work, ma'am. So you have done the survey of the malware detection. So I
Yes, sir.
guess your research is in this area. So
Yes, sir. I'm
so
making the
in that,
framework. Yes, sir.
yeah.
I'm making
So
the framework to detect the
yeah,
malware, specifically polymorphic malware and fileless malware.
okay. So one of the research gap that you have identified is the need for cross-domain, cross-platform detection. So
Yes, sir.
uh,
Yes, sir.
how are you like? There are no systems as of now for this. And
There are
what will be the approach to achieve this cross-platform detection?
there are existing systems are there, which are there. But if we considering the cross platform, like if we consider the IoT devices where if we take the data set, suppose considering data set is network, a particular network, and if we apply that particular framework which we use for finding out that particular malware, that is not working on if we consider the IoT data set, or if we consider the cloud network over there. So that one thing I find out, that cross platform work must be carried out if we particularly finding out the malware for particular network.
Okay. Okay. Yes, ma'am. Thank you. Thank you.
Okay, thank you.
Thank you, Pallavi ma'am, for your presentation. Now I'd like to invite the next presenter. Next, we have Pragati Guduru from Manipal Institute of Technology. And she will present the paper titled A Comprehensive Review of Hand Sign Recognition System.
Hello, good afternoon all. I'm going to present on comprehensive review. Can you see my screen?
Yes, it is visible.
Yeah. Hi, this is Pragati. I'm currently pursuing my master's in MIT. We gone through we selected this topic because we are working on a model related to this one. So to help the future researchers, how I faced a lot of issues while reviewing all the hands and recognition systems in the previous years from the researchers. So that's why we gone through this. We suggested this paper, this one as a review paper. So current. Yeah. Yeah. As we all know that hands and recognition system is with new technologies, it will help for the people, and the advancement in the machine learning and artificial intelligence and deep learning will help to assist the people who are especially impaired, and that nowadays it is helping a lot, but still we can improve a lot of things for the people which is a basic need to communicate with others. So that's why we gone through this paper. What is the evolution of reset technologies in these hands and recognition techniques? So the communication broadly categorized into verbal and non-verbal, as we all know. So verbally we don't have any issues to we can speak, but non-verbal we are using facial expressions or hand movements and American Sign Languages to help the people to talk in any work area or anything. When a people with physical impaired or anything, they have to communicate with others. So they are using that way. We got this model. So as we know all know, in non-verbal work question also we have static and dynamic. And static refers to the fixed positions, fixed hand gesture positions that we have, like American Sign Languages and number to show with their fingers like 1, 2, 3, like that we can show. And dynamic with positions, like there is a sign language that we have in all things that we learn from the moving hands systems. So there are two major approaches that have after going through the papers that we got to know that the cloud-based system and vision-based systems are there. So the human hand is a 24 degree of freedom. Like we can move our hand in a 20 every angle of hand between that 24 degrees. So the cloud-based system is good, but it's still we have a lot of uncomfortable when we are wearing the people with this. So they are, and it is expensive because of sensors and all other cost effectiveness will be more. And for vision based systems we have a lot of computation and cost effective, but it's still people are trying to use that one, because using smartphones we can communicate and by texting and by modifying anything. So my main objective of this paper is to review and compare the the discrete Fourier transform methods and various classifiers, including FPGA and implementation using ANN algorithms, and investigating methodologies in DFTV using radial bias classifiers. Like in previous papers, they have a lot of techniques of old discrete Fourier transform method. It's a good method. It helps a lot, but it was outdated as per now. But still it's using currently using you with MATLAB also. We tried in our investigation of papers of all the reviews. and evaluating all AI models which recently implemented, and comparing the artificial INN network-based approaches and their optimizations. So traditional system for hands-on recognition used for discrete Fourier transforms, and there are challenges in this one for DFT, like whether for DFT, when we have to use DFT, we have to go through, like we have to take a any gloves where that one take a picture, I mean take a data set or train the data set, and then it will create a outer layer of that one, and then it will be seen the graphic of DFT. That was recently, I mean previous paper, the previous works of all other researchers was done. And for AI based approaches, they taken the data set of any sign language and they trained the model. After training the model, they tested, and they, if we give the input of some image, it will detect as that image as this according to the training of the data sets. And for limitations and other things, that each model, for two models there is a lot of limitations and drawbacks also there, according to the accuracy and efficiency of the models, and cost is major fault of this, both models will be there. And we thought of combining both models as a hybrid model, to explore that hybrid models of combining both traditional and latest models to approach. As per I category, I mean, while gone through, I got to know that there are two approaches: vision based and data cloud based. In vision based, also they have classifiers like hybrid classifiers and mapping, self-organizing mapping classifiers are there, and radial bias classifier. There is a small variations in the each classifier. While I gone through the paper, each for each 2 years or 3 years, they created new model from DF. Firstly, DFT started, then they added hybrid classifiers, and then they started radial classifier, like horizontal vertical analysis of an image only, but they added few classifiers to detect more, get a more accuracy and efficiency of that model. So as per now, vision based model mainly depends on the feature extraction of the things. So combining these two classifiers, they try to increase the speed and accuracy. And for real time applications also, radial bias classifier is good model, compared to I mean compared to, not like, it's a good model, but hybrid is also good model, hybrid classifier. But still, radial bias classifier is latestly, I mean with good work it is there. And for database model, we have data acquisition and ANN classifiers. Data acquisition, that sensor clouds collect a lot of real-time data using, if a person uses it, collects a lot of real-time data. It helps, but as per getting feedbacks from the users from previous research papers, we got to know it was a little bit uncomfortable for them to use and gloves where anywhere where they are going. So that's why they tried with mobile. They want to create an app to mobile for communication for them. That was in an algorithm will help that one with mobile communication, that is there. And FPGA development is for after training that model, they converted that into a FPGA, dumped that data sets to the FPGA to get an hardware results. So these are the class analysis we done. There are all these algorithms which are based on from past 10 years. So this will help to they get an overview for the other researchers, like how many algorithms are there, how they are working, what is the drawbacks of each algorithm, how that helps the future researchers to get to know whether which what will happen if we add few more things like that in that one. And the conclusion was like, we are, as per now, we are trying to hardware to software model. So to help what we are doing is we are taking a data sets and training that model, and then using Xilinx, we are trying to develop the block diagrams for that. And after creating block, then we are trying to dump that blocks to FPGA to get the results. But it's a huge model, because combining hardware and software taking a lot of things to track. As per now, that system, I mean that models of that one is there, but still we are trying to optimize that one because last models were somewhat having less accuracy. Other things are there, so we are trying to make that one. So as per the conclusion of my paper, this paper, of traditional methods and AI-driven like convolution neural networks, these improves accuracy and adaptability and performance as per now. While DFT, like the last old models are there capable, they are using for health models and robotics also. So whatever new models are there, they are using, but still they are having some small fluctuations and drawbacks whether when they are using in healthcare and other things. Because when they are doing operator, with robotics, they need some accurate points because we can't give our overall control to the robotics as per now because of training. We need metadata to train them more data. So that's what the disadvantages as per now. That's a challenging, but still for in the future we may get more data, more data for training that robotics and hand science movements, so that helps the other with the hospital and healthcare, other agriculture based also. They can help in the farming and other things for the hand movements. Thank you. Any questions?
Yeah, for the sign language detection, so you're planning to use the Indian Sign Language or the American Sign Language?
American Sign Language, sir.
Okay, so don't you think like there are many research that has already been done using deep learning algorithms like CNN and all?
Yes, sir. We have gone through that one also. Only I think we have found five or six things that based on CNN algorithm currently, and that's we are also working with CNN only. But their accuracy up to 97, 98 got there, but we are trying to more get 99 accuracy for the training of models, and then in hardware also we are trying to get that much percentage.
So in the hardware part, like what are you having in the hardware part, sensors
In
and everything?
hardware part, in Xilinx there is a method, sir, like we can train some whatever input we are giving, we can give it as a 0 to 256 bits like way, that as a input. And after getting giving input in to a block diagram, that block consists of DRM and other blocks like controlling art. In RTL code we are trying to develop something, so we are trying in a new way.
Okay. Okay, fine, fine, good. Good.
Mhm. Any question? Thank you, sir.
Thank you, Pragati, for presentation. Now I'd like to invite next presenter. Next we have Nikhil Wag, and he's from Vishwakarma Institute of Technology. Will present the paper titled Book Recommendation Platform. Nikhil, are you in the meeting? Is there anyone who's like to present the paper on behalf of Nikhil from their co-author? Okay, I think so. No one is available from this paper, so we move forward for the next presenter. Next, we have Maria Jose from Amrita Vishwa Vidyapeetham. She will present the paper titled Consumer Reactions to Greenwashing Awareness Attitude and Actions.
Good afternoon, sir.
Yeah.
Yeah.
Maria, you may please proceed with the presentation.
Yes, sir. Hmm. Sir, is my slide visible?
Yes, it is visible.
Yeah. Yes. So, myself, Maria Joseph. I am research scholar from Amrita Vishwavidyapeetham, Amritavati, Kollam, Kerala. And my topic is consumer behavior and response to greenwashing, awareness, attitude, and action. So, greenwashing refers to the practice of making false or exaggerated environmental claims to mislead consumers. It has become a significant concern as consumer demand for sustainable and ethical products increases. And the industry is affected. The common in sectors such as food, fashion, and beauty, where brands capitalize on sustainability trends without meeting the environmental standards. And the objectives of my study includes to assess the frequency with which consumers encounter environmental claims on product labels and advertisements, to evaluate the relationship between consumer awareness of greenwashing and corrective consumer behaviors, that is boycotting or seeking transparent alternatives. And the last objective is to investigate the role of emotional responses such as frustration and distrust in driving the corrective action plans in response to greenwashing. And my literature review includes this. So, do I want to read this or want to skip? Excuse me, though.
Yeah, it's fine, fine. You can go ahead.
Yeah, so literature review means greenwashing, deception in sustainability, the misleading environmental claims to attract the eco-conscious consumers, often vague, exaggerated, or unverified sustainability promises, and why the consumers fall for greenwashing. And from the literature review, identified that it may be due to the cognitive dissonance or emotional reactions or maybe the brand mistrust, the awareness gap, why this greenwashing is hard to spot. It may due to the confusing claims and lack of transparency, or the cognitive basis such as confirmation bias or the halo effect. And how does the consumer react to this? They may boycott the brands, or they may seek verified alternatives, or they social media backlash. And the power of transparency and certifications is the honest, verifiable sustainability efforts build consumer trust. The third party certification helps to distinguish genuine brands. And the long term impact of greenwashing is the loss of trust in brands and sustainability efforts, the declining loyalty of consumers, reputation damage. And the research methodology I used was the research approach was a mixed method techniques combining both quantitative and qualitative data. Data collection was the survey with 20 questions, that is multiple choice and Likert scale questions, assessing the consumer's awareness, emotional responses, and behaviors related to greenwashing. Literature review provide contextual understanding. The study was conducted in Ernakulam district, Kerala, and which is distributed online. And the sampling method was a convenient sampling to reach a diverse consumer basis. The data was analyzed using SPSS, and the descriptive statistics was used to summarize the consumer awareness, emotions, and corrective actions. The chi-square test to assess the relationship between awareness and corrective actions, and the multiple regression analysis to identify the key influencing factors. These are my results and findings. The first one is about the descriptive study, and that table reveals that the environmental claims in marketing are common, with 68% of respondents encountering them regularly or frequently. However, only 35% felt confident identifying greenwashing, highlighting a significant gap in consumer awareness and critical evaluation skills. Despite this, 55% reported boycotting brands over false environmental claims, showing that many take action based on the ethical concerns. While some seek third party certifications or speak out on social media, most prefer personal corrective actions like boycotting. The next one is the chi-square test for test the association between the consumer awareness and corrective actions. And the chi-square test reveals that a significant correlation between the consumer awareness of greenwashing and their likelihood to take corrective actions such as boycotting deceptive brands. Similarly, the consumers with higher awareness are significantly more likely to seek out transparent brands. And these results suggest that the increased awareness of greenwashing strongly influences consumers ethical purchasing behavior. Overall, the findings highlight the importance of consumer education in promoting more sustainable and informed buying decision. Next one is to analyze the test was multiple regression analysis for factors influencing the corrective actions. And the results indicates that And the results indicates that it identifies the emotional reactions, particularly frustration, as a strongest predictor of consumer taking corrective actions like boycotting. And the brand transparency also significantly influence such behavior, indicating that transparent brands are more likely to be trusted and supported by consumers. And the awareness of greenwashing further contributes to corrective actions, suggesting informed consumers are more proactive in seeking transparent alternatives. And these findings emphasizes the need for brands to provide a clear, verified sustainability information to build trust and reduce the negative responses of the consumers. The next one is to identify the emotional response to greenwashing. The survey shows that frustration and distrust are the most common emotional reactions consumer have toward greenwashing, and indicating strong negative sentiments towards the deceptive environmental claims. Less frequent actions like anger suggests that the consumers experience a range of emotions when faced with misleading sustainability messaging. And these emotional responses, particularly this is frustration and distrust, are key drivers behind consumers decision to take corrective actions such as boycotting or seeking more transparent brands. The final one is to identify the brand trust and the corrective actions they had taken. And the data shows that higher brand trust significantly reduces the likelihood of the consumers taking corrective actions such as boycotting, with 75% of the low trust consumers boycott, compared to only 30% of the high trust consumers. Similarly, 85 percentage of the low trust consumers seek transparent alternatives, compared to 65 percentage of those with high trust, highlighting brand trust as a major factor in consumer decision making. And this suggests that consumers are more forgiving and loyal to brands they perceive as trustworthy. Maintaining an authenticity and transparency is therefore essential for brands to build trust and avoid the negative consequence of greenwashing. And coming to the conclusion and recommendation part, the main conclusion of my study was the greenwashing strongly impacts consumer behavior, that is, they influence the trust, emotions, and awareness. And low confidence in identifying greenwashing highlights the need for consumer education. The emotional reactions drive corrective actions like boycotts. The brand trust is very crucial. The consumer act against unreliable firms. The transparency and authenticity are vital for brand loyalty and reputation. Policymakers must enforce clear sustainability guidelines to prevent deception, and educated consumers promote ethical and sustainable purchasing, fostering a transparent market. And the recommendations of my study: enhancing consumer education by providing improving a brand transparency and authenticity, address consumer emotions and trust, and strengthen the regulations and standards, and encourage the ethical consumerism. That's about my study, sir. Thank you.
Yeah, it's a well done study. So, what was the size of your universe and the data sample?
So it was about around 300.
This was the size of the universe and the sampling data.
Oh, sorry. So actually, the size of the universe was around. It was around. I think it was around 1,000, and I selected 31 people according to my conducted my study through convenience sampling. So for my convenience, I selected 300 people from the whole population.
Okay, and what was the age group of this survey?
So it was generation Y and Z.
Okay, okay. And did your survey had question about their awareness about what greenwashing is all about?
Sir, I particularly mentioned what is greenwashing in that question because some may not be aware about this term. So that
Right.
particularly mention what was greenwashing, so that I think that while answering the questions, it may help them.
Okay, okay. Good work.
Okay, thank you, sir.
Thank you.
Thank you, dear author, for this presentation. Now I'd like to invite the next presenter. Next, we have Shrey Rai from Viswakarma Institute of Technology, and he will present the paper Multi-Thread File Sharing System Tech Stack, Java Sockets, Multi-Threading. Shrey, are you in the meeting?
Yes, sir, I'll be sharing screen now.
Yes, please. Please go ahead.
Sir, is my screen visible?
Yes, it is visible. Please go ahead.
Okay, good afternoon, sir. I am excited to present our project titled Multi-Thread File Sharing System, which we developed using Java Socket and multi-threading. In today's digital world, file sharing has become a fundamental requirement across organizations. So, file sharing has become a fundamental thing about organization, academic environment, and collaborative platforms. However, traditional file sharing model, the client server architecture, often suffers from critical issues like single point of failure, poor stability, and network bottleneck when multiple user access the system concurrently. These limitations inspired us to build more reliant and efficient peer-to-peer file sharing system. So our problem statement is basically the traditional client-server file sharing system has existential these problems that I just concluded. To support multiple file sharing process at once, we implemented Java multi-threading where each client request is handled independently through separate threads. So in objects, we developed the peer-to-peer system to avoid the central dependency via which it can conclude many things through it and ensure multiple concurrent file might transfer via using threads only. And thread safety was ensured using synchronized blocks and Java locking mechanism, preventing race conditions or inconsistent data states. And in literature review, we have studied around 15 to 20 research papers, but these are the ones which match the most. So past research paper shows that used multiple threading for efficient and improved using of optimized thread allocations. Java sockets provide more fast and secure transition. So we used them both, and via multi-threading we can also do multiple file sharing concurrently at the same time. For security, we adopted AES encryption so the data transfer between peer remains private and protected from unauthorized access or interruptions. Uh, Let me show you via system architecture. Here, as you can see, our system flows peer-to-peer architecture. Each acts both as client and server, both so that we can share multiple files, and it has almost eight main objectives that can connect via it: peer node, service class, client handler, thread, connection handler, file manager, request detector, and thread pool. These are the main which connect via this, and GUI is for used for its front end and make it look good. Implementation strategy. We designed lightweight custom protocol for request response, which enables peer to seamless communicate request file and confirm transfer. The entire system was built using core Java features, especially Java Socket APIs, making it cross-platform, easy to maintain, and robust. We conduct a series of performance tests over these two, and like core components were over there: thread peer client, client connection, synchronize blocking to prevent race conditions, and encryption data packets via AES. We can have those encryption data packets which prevents it from mixing, or it cannot be detached from their own peers. And experiment experimentation, the result shows significant improvement in latency and CPU efficiency, and the system successfully handled concurrent connection without performance degradation. uh, Here we simulated around 4 to 6 systems over here. File were of various size ranges, about like varying from 900 kbs to around 100 mbs, and it was smooth to transition. And measuring speed that we used were speed of it going from one to another and sharing it, and CPU usage and latency, for which we saw that, and latency dropped by 30 to 40% using the multi-threading, so that it makes it more faster, and concurrent transfer were stable and fast. Because of AES, there were no security breaches too, and CPU usage remained optimal and active threads. For future scope, to make the system more advanced, we plan implement the key cryptography RSA for the added security, introduce load balancing for the large scale networks, and optimize the bandwidth. It currently have only limited bandwidths in it, so we can add more bandwidths to it and add transversal to support those. So, sir, in conclusion, we can say that this project allowed us to apply all the theoretical knowledge of disturbed system concurrency, cryptography to real world scenarios, and result validate our approach. We believed our multi-threaded file sharing system is not only scalable and secure, and Java sockets efficiently handle the network communications. The system is secure, scalable, and efficient. The solution is suitable for academic, professional, and all the enterprisal file sharing needs. Okay.
Yeah. Uh, what is the relevance of this project when we have many systems that have been already developed, like using cloud or other peer-to-peer uh,
Sir,
body?
peer-to-peer, it has the relevance like that. Yes, Google Cloud may have dual channels and all, but via multi-threaded threaded embedded system, it can comply datas over that, and the size of those files sharing via it will be more efficient and more faster.
But don't you think in in Java sockets are highly irreliable. They can't be reliable for the connection. So if the file size is on a larger side, then there is a possibility that the socket connection is lost and the file is lost.
No, sir. Via
Same.
AES, there are very less chances for it to get the file loss. And for Java socket in the future, so we have mentioned that we might use NAT transversal and connection persistence for real world deployment. So it will reduce that strength over there, reduce
Okay.
the chances of file losses over there.
Okay. 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 Fine. Thank you.
Thank you, sir.
Thank you, Sharif, for this presentation. Now I'd like to invite the next presenter. Next, we have Ayushi Sain Sharma. She will present the paper titled Rewarding Fathers, Penalizing Mothers, a quantitative evidence on the unequal gains of parents in Indian labor market. Ayushi, are
I'll
you there?
just, yes, yes. I'll just share
Yes.
my screen.
Yes, please present.
Is my screen visible?
Yes, it is visible.
Yeah. Good afternoon. My name is Aishi Sen Sharma, and today I will be presenting my research paper titled Rewarding Fathers, Penalizing Mothers, a quantitative evidence on the unequal gains of parents in the Indian market. This was done under the supervision of my professors, Dr. Ashish Sharma and Dr. Swati Agrawal, affiliated with Christ University. So, in this study, we will try to quantitatively measure how parenthood affects a person's chances of getting job and how much it affects their earning in India. We will apply interactive multiple regression models, and we will also try to understand the impact of different household types and number of children on employment and wages. The keywords are motherhood penalty, fatherhood bonus, employment to population ratio, mean nominal monthly wages, which we will try to understand later on in the later slides. So the labor market is already plagued with very deep-rooted gender disparities. But when we add on another layer of parenthood, we see that there is a different layer of inequality. So women after becoming mothers often face something known as motherhood penalty, which just means that after they become mothers, they experience reduced employment opportunities, wage stagnation, slower career progression. While males, on the other hand, enjoy a fatherhood bonus, that is, receiving higher wages, better job security, enhanced professional prospectus. So, one of the main reasons behind this is the deep rooted gender norms and workplace biases, which leads to such unequal gains for parents. While these dynamics have been largely studied in developed nations, it is still there is very limited study about this for developing economics like India. So, the literature review, it is seen that motherhood penalty is one of the major contributors to gender discrimination in the labor market. So, one of the main reasons is employer bias against mothers and favoritism towards fathers. Employers often have this perception that mothers are less reliable, less committed, or distracted, and are much more better at nurturing and caregiving duties. While they have this perception, very opposite perception for fathers, that they are stable, responsible, and the primary breadwinners of the family. So this is also like from a young age, women are conditioned to value nurturing, while men are encouraged to lead and earn. So the this shows that there, since early childhood, there has been such stereotypes, which later on affect us even during parenthood. So this table basically shows like a comparison between motherhood penalty and fatherhood bonus, where we can see that there is a minus 4% wage per child for mothers, while there is a plus 6% wage for fathers. There's minus 4 to 5% wage penalty per child, plus 6%. And whenever mothers or fathers they have applied for jobs, there is 7% less callback rate for mothers and a plus 6.4% callback rate for fathers. Um, for the Indian context, what we see is that motherhood significantly reduces laborhood force participation, and also this is due to issues like minimal child care facilities. And one more integral research gap is that most of these studies are only focused on how parenthood affects on women only, but they don't really actually have any evidence about what actually happens to men. And there's employer bias favoring hiring young unmarried women to avoid maternity related leaves. And only 11% of Indian companies actually offer daycare services, which shows that not much importance is given to daycare facilities, which are integral for mothers working. Then Maternity Benefit Act grants 26 weeks of paid leave to mothers. But while there is 15 days paternity leave in India, it's not like It's only meant for the public sectors. There's no standard paternity leave given by private companies. So the main research gaps that I've identified is that there is a lack of Indian evidence on long-term parenthood effects. However, we have tried to tackle that by using data from International Labour Organization, specifically for India. Then there is a lot of research papers which have only talked about how parenthood has impacted mothers only, but not much has been talked about how it impacts fathers. In my research paper, we will try to understand whether there's a fatherhood um, bonus actually prevalent in India or not. There's no integration of household type and number of young children. In India, different household types might actually influence childcare duties a lot. For example, in an extended family, maybe childcare can be handled by the grandparents, so the woman can still work. So this is also an integral factor, and there is limited use of quantitative models in Indian literature. We will be using interactive multiple regression model, and there is a lack of dual analysis between both employment and earnings. Most of the research papers have only talked about either employment or earnings, but not both of them. But in my paper, we will try to focus on both of them. So the main research objectives are: does parenthood actually affect a person's chances of being employed in India? How is it different for um, males and females? And how does the number of young children affect employment chances? Does household structure influence employment outcomes for parents, and how it affects the monthly earnings? So we will be using two data sets from International Labour Organization. First is the employment data set, which is the prime age employment to population ratio by sex, household type, and presence of young children in percentage, which is an annual data. The time period is 2000 to 2024. It basically measures the employment participation for individuals uh, of the age 25 to 54, and includes variables like gender, household structure, number of children under the age of 6. So the main reason why we have selected this data set is to understand how parenthood impacts the
Sorry to interrupt you,
percentage of the
Ayushi,
people.
but you have last 1 minute for the presentation.
Oh, then I'll skip to the main results. So, in the results, we see that men are 44.97 percentage points more likely to be employed than women, even before we consider parenthood into the picture. And then for household type, only one person household type is significant. So compared to childless married women, 14.78 percentage points more likely to be employed. Other household types are not statistically significant. So this is the main part where we see the motherhood penalty. So we see that for one child, there is 12.39 percentage points less likely to be employed. And when there are two children, it is 17.27, and 3+ children, it's 19.09. So as the number of children increases, the percentage of women being employed decreases. So the interaction term, which basically tells us how is it different for males with children as compared to women. So when having one child, women's employment to population ratio drops by 12.39%, while for males it drops by 0.47. Then for two children, it's 17.27 percentage points, and for male, it's 3.87. For 3+ children, it's 19.09 percentage points, and for men, it's 5.7 points. So while there is for 1 and 2 children, there is a negative impact. As compared to women, this is also very less figure. And only when it is 3+ children, there is a positive effect on males. So the R squared is 88%, which shows that it is like a good, all the variation is explained by the independent variables, and even the adjusted R squared is closely. P-value of the statistic is highly significant. So the next model is for the mean nominal monthly earnings. So there is a huge
Ayushi,
inherent.
kindly conclude.
Okay. So overall, um, overall, we do see that like there is one we see that women in India do face a strong motherhood penalty both in employment and as well as the mean nominal monthly earnings. But what is surprising is that fathers, while it is expected globally that they have a fatherhood bonus, it is seen that for wages this has not translated in India. It is only for rather they have much more wage penalty as compared to females. So one reason for this might be that men may stay employed out of financial pressure, even go like accepting lower paying or insecure jobs to support their larger families. So, in conclusion, we'll say that contrary to the global evidence that there is a fatherhood bonus, this has not translated to India, and the motherhood penalty is strongly evident. Limitations are that while we have used various data points, it is also seen that initially they were recorded on a 5-year basis and then suddenly in a yearly basis. And then mean nominal monthly earnings data is a short-term data. There is also lack of data on motherhood in India. And there are also a lot of variables that have not been taken into account into the existing data sets. So these are the references. I would like to acknowledge my mentors for supporting me and guiding me. Thank you.
Yeah, quite an interesting research actually. So as you have mentioned in the limitation itself, so there is a gap in with regards to the data in the Indian perspective, right?
Yeah.
So yeah, so based on that limitation, your research work is very good. So that aspect that needs to be highlighted actually. So you can take it in the later period if possible.
The due to missing data.
Yeah,
Okay.
yeah. So yeah, good work, good work.
Thank you.
Thank you, Ayushi, for this presentation. Now I'd like to invite the next presenter. Next, we have Pranav Banker, and he will present the paper titled Seamless Data Orchestration and Analytics Pipeline for E-commerce using Azure. Pranav, are you there in the meeting?
Yes, sir.
Yes, you may please proceed.
Okay. So, good afternoon, everyone. I'm honored to present our project title, Seamless Data Orchestration and Analytical Pipeline using Azure for E-commerce. I'm Pranav Bankar, and I will be representing my project team, uh, Professor Rupali Parte, Professor Vaishali Kapure, Avdut Khandagale, and Shrutika Manzarni. So, let's start with the presentation. So, our presentation will walk you through the sections which include introduction, problem statement, literature survey, system architecture, technologies used, machine learning models, data pipeline implementation, visualization, and deployment, key achievements, and finally the conclusion. So let's begin with the introduction. So e-commerce has been one of the largest data generators in recent years, which produce massive amount of transactional, behavioral, and logistical data every second. Manual analysis of such vast data is not only inefficient but also delays critical decisions. So we aimed to solve this problem by building a automated and end-to-end machine learning pipeline using Azure services. So the core goal was to help business make faster decision through fraud detection, sale forecasting, and customer segmentation, which is powered by interactive visualizations and analysis. So coming towards the problem statement, the key challenges we identified were: how can we process and analyze e-commerce vast data while keeping it scalable? How can we automate the data flow from collection to insight? Can we integrate multiple learning models under one pipeline while maintaining modularity? and how can we make the output accessible and actionable for business users. These challenges shaped the architecture of our system. So, coming towards the literature survey, our work is grounded in recent and relevant researches. First one is MUNEP, which highlighted the need for automated modular pipelines in cloud system. Then Aziz demonstrated how Apache Spark improves real-time analysis compared to traditional batch system like Hadoop. Next, Conner and Alfred Ross showcased how Azure ML streamlines the entire model lifecycle from stunning to secure deployment. Then Knuckles emphasized Azure's storage tools like Data Lakes and Synapse as scalable solutions. Next, Sable proved how AI strengthens cloud cybersecurity through behavior analysis and anomaly detection. These works helped us validate our technology and stack the architectural design. So, coming towards the architectural design, here is a view of our architectural design. So, first is the data source. Data source includes HTTPS, APIs, and SQL databases. Next is data ingestion, which has Azure Data Factory. And then raw data is stored in Azure Data Lakes Gen 1. Then the pre-processing of data is done using Apache Spark. Then for enriching of the data, we have used MongoDB. And then showcasting the results of the machine learning, we have used Streamlit. And then pre-processing of the data is stored in ADLS Gen 2. Then the data warehousing is done in Azure Synapse Analysis. And at the last, visualization is done in Power BI. This is the modular design ensuring flexibility and automation. So next is the technologies used in the project. So we have a wide range of tools and services from Azure ecosystem, which includes Azure Data Factory. Next, Azure Data Lakes and blob storage for scalable data management. Then Databricks and PySpark for distributed data processing. Then Scikit-learn and Keras for machine learning model training. Then the Streamlit for front-end deployment of the ML models. Next, Power BI for interactive business visualizations and Azure Streamlit analysis for warehouse level analysis. Next, talking about the machine learning models, we have implemented four ML models, which includes K-means clustering, which were used for logistic optimization. And next one, ARIMA and LSTM for sales forecasting, isolation forest for fraud detection, and random forest classifier for order cancellation prediction. Next, coming towards the data pipeline implementation, here is how a pipeline works end to end. First, the data is pulled from API, GitHub, or SQL. Next, it is taken to data Azure Data Factory, automates ingestion using lookup and for each. Then Spark in Databricks handles the transformation of the data. Next, the ML models are trained and saved to Azure Blob Storage. And then the Streamlit server predicts automatically interactively. And next, Azure Synapse stores the result and Power BI visualizes them. So coming towards the visualization part, we have prioritized users' accessibility and clarity. So Streamlit is used for interactive with model and output views. And the Power BI offers dynamic dashboard for sales forecasting, fraud detection, and segmentation. And it enables users to make a decision. Next, coming towards the key achievements, our key achievements are for ML model integration into one pipeline, fully automated architecture, real-time prediction and insights, then Streamless-based dashboard for usability, and Azure cloud storage for scalability. So conclusion is our project has shown how cloud and ML can transform e-commerce analysis. It's scalable, automated, and user-friendly. So thank you for your time.
Hi. So you have already implemented this.
Yes, sir.
So what are the costs involved? Like if I'm talking about a large scale e-commerce website like Amazon or say
Yes, sir.
Flipkart, Myntra. So what will be the cost involved?
Sir,
Ye-
so we have used a data set from Kaggle, which total we had 8 data sets, and each data set had lakhs of rows. So we have used that data sets.
Fine, data sets is fine. So if I'm talking about you're using many Azure services as well, right?
Yes, sir. Yes.
So and you will be using it for the forecasting and also the visualization part and all the different services that you are giving. So my
Yes, sir.
question is, what do you think, or what have you done the cost analysis?
Yes, sir. For that, we have actually used Azure services using the student GitHub free account, which gave us $100 credits. So out of that, we have used $20 credits.
Okay. So in the real time basis, what do you think will be the cost involved?
Actually, sir, we have not gone through that, but we have seen as compared to the actually what we have used. So we have used
Okay,
$20 for that.
okay, fine, fine. Good work, good.
Thank you, sir.
Thank you, Pranav, for the presentation. Now, I'd like to invite our next presenter. Next, we have Mangala Tanushree, and she will present the paper titled Secure Temporal Crime Rate Prediction Using Hybrid Machine Learning Models with Socio-Economic Feature Integration. Tanushree, are you there in the meeting?
Yes, sir.
Yes, you may please proceed with the presentation.
Good evening, everyone. I am Mangala Tanushri, currently pursuing my BTech at KL University. Today, I am excited to present our research title Spatial Temp. I'm sorry, sir, I'm sharing my screen. Sir, is my screen visible? Hello, sir.
Not, it is not yet.
Sir, now is it visible?
Yes, it is visible now. You may please proceed.
So, good evening, everyone. Myself, Shri, currently pursuing my BTech at KL University. Today, I to title
Uh,
Spatio-Temporal Crime Rate Prediction using Hybrid Machine Learning Model with shortened and a timely challenge. How can we use machine learning along with the social and economic indicators to predict where and when crimes are likely to happen? Our goal is to support smarter data-driven policy and policy making for safer communities. So the main agenda of the presentation is we will begin with the background and the motivation behind the crime prediction, then review the gaps in the existing approaches. Next, I'll explain about our dataset pre-processing steps, hybrid model architecture, and we'll evaluate the results, feature inferences, and the hotspot visualization which we have got. So, crime rate prediction is more than just analytics. It's a step forward preventing harm and creating safer cities. Traditional policing is most reactive. A crime occurs and then action is taken. But what if we could anticipate high risk areas based on the historical patterns and the social context? That's where machine learning helps us. It allows us to detect the patterns in both when and where the crimes are likely to happen, and more importantly, with this, law enforcement can shift from reactive to pro-reactive interventions, ultimately improving the public safety. So, coming to our research objectives, our research aims to develop a hybrid machine learning model that goes beyond just analyzing past crime records. Instead, we focus on predicting crime rates by considering where crime occurs, when did they happen, and importantly, under what social and economic conditions they tend to rise. To capture these underlying factors, we integrated socio-economic features like literacy rate, unemployment, GDP per capita, and population density. These indicators helps us to move beyond surface level numbers towards a deeper understanding of drivers behind crime rates. The scope of our work extends beyond academic analysis. Our goal is to equip law enforcement agencies and policymakers with actionable insights, enabling smarter resource development, proactive planning, and targeted interventions in high risk areas. At its core, the research investigates whether combining spatial, temporal, and the socioeconomic is unified in a unified machine learning framework can lead to more accurate and impactful crime prediction. This objective forms the foundation of our entire study. Coming to the existing works and the gaps. Well, crime rate prediction using machine learning has been explored, but there are many major limitations. Firstly, most models use only past social and economic conditions like poverty and unemployment. Second is like existing model often ignored like spatial patterns where crime happened, and temporal data like which month at what particular time it happened. So our model focuses on the time and the location also, and we use few social economic data, especially in the Indian context. So our model integrates these gaps by integrating social, economic, spatial, and temporal features using a hybrid ensemble approach with the random forest and exiboost. Coming to our data resources, we have seen the types of data. So we started with the crime data from National Crime Records Bureau. This gave us the yearly crime counts from each state and became our target variable, what the model is trying to predict. Then we brought into the socio-economic data from census and the government portals that included the important variable like literacy rate, unemployment, GDP, the all social economic factors. To merge this with our crime data, we used a state and year as a common keys. For an missing values, we used interpolation and the closest available years data. Next, we added the temporal features. These were extracted from the year column like month and the season, which helped us to capture seasonal crime patterns. For example, crimes that may rise during festivals or summers. So in the end, we have single unified dataset where each row represents a state in a given year, and each column was a feature, either a crime count, social economic condition, or a time-based indicators. And next, coming to our pre-processing steps. First, we handle the missing data. For socioeconomic data, we used median imputation. This helps to avoid bias caused by the outliers. Next, we applied the min-max normalization to scale like GDP and the population density to the common range. Then we performed a one-hot encoder for categorical variables like crime type and the state, converting them into a numerical format so that the model can process them. Finally, we use cyclic encoding for time features like month and season. For example, January and December are closer in time than January and June. Cyclic encoding helps the model recognize these periodic relations. Together, these steps ensured our data was clean, consistent, and ready for the accurate training. Next, coming to our feature and engineering. To select the most informative features, we use correlation heat maps, recursive feature elimination, and domain knowledge. And then from that, we found the final feature set that included crime type, literacy rate, GDP per capita income, unemployment, population density, uh, state, and the month and the year. Coming to our model, we have used a hybrid model framework to improve the accuracy and the reliability of our crime rate prediction. We built a hybrid ensemble models using two well-known algorithms known as random forest and XGBoost. Let me briefly explain why we choose these two models. Random forest is excellent at capturing non-linear linear shifts between features. It also gives us a feature importance scores, which helps in understanding what factors contribute most to the crime rates, making the model more interpretable. On the other hand, we use XGBoost because it is a high performance model that uses gradient boosting. It focuses on improving prediction accuracy by learning from the errors and is highly optimized for speed and performance. Rather than choosing one model, we decided to combine both of them using a method called soft voting. In soft voting, each model predicts a probability for each class, and we average those probabilities to make the final decision. This helps in balancing predictions, reducing bias from a single model, and improving the overall stability. The hybrid setup gives us a more robust and generalized model capable of performing well across different crime types and the geographical regions. Coming to our model evaluation and validation, our model was tuned to ensure it was not just accurate but also reliable and generalizable. Followed a two-step evaluation strategy. First, we use a standard 80-20 train test split where 80% of data was used for training and the remaining was used for testing. Second, we applied five-fold cross validation to avoid overfitting. This technique splits the data into five parts, trains on four, and tests on one remaining, rotating the each type. It gives us a more stable and the estimate of the model performance. For evaluation, we didn't rely on just one metrics. We used accuracy, precision, recall, F1 score, and ROAC curves. Together, these metrics ensure that our model was fair, balanced, and worked well across all the crime categories. Coming to our results section, here's how our model performed. Random forest alone gave us the accuracy of 88.4 and XGBoost gave us accuracy of 89.7, where our hybrid model gave us a more accuracy that is 91.8. We also saw the improvements in the precision, recall, and F1 score by all the models. Coming to our influential features, we analyzed which features influence the prediction more. The top contributors were unemployment rate, population density, and the income level. This aligns with the criminological studies that links economic stress and the urban congestion to crime rates. A model not only predicts crime but also highlights the social factors behind it, which is crucial for informed policy decisions. Coming to the crime hotspots across the Indian states, using a state level data, we created a crime heat map showing the intensity of the crime across India. States with higher unemployability and lower literacy often showed higher predicted crime rates. These maps provided actionable insights for authorities, for example, where to increase the patrols, where to deploy the awareness campaigns, or where to invest in the education or the job program. It transformed prediction into a policy guidance. This kind of visualization adds a practical dimensions to our model output. Coming to the conclusion, we proposed a hybrid machine learning approach that combines spatial, temporal, and a social economic feature to improve the crime prediction. Our model outperforms standalone model in the terms of accuracy and the interpretability. The social economic integration adds value not just for the prediction but also the understanding and preventing the crime. Coming up to our future work, looking ahead, we plan to use real time data feds from news and social media, including city level crime mapping, explore deep learning models and ethical AI approaches to reduce biases. The goal is to build a system that's scalable, reliable, and the social responsible. Thank you so much, sir, for your time. Any queries?
Yeah, nice work. So, my question is regarding, I want the clarification regarding a data set. So the data
Yes,
sets
sir.
that you have used for socio-economic conditions and the crime rate, this is from the government website, right? Data.gov.in. Am I right?
Yes, sir. Yes, sir.
So, what is the granularity of these data? So, social economic conditions, that this is state-wise or city-wise? How
That
is it?
is state-wise. We didn't go into a city. That is what our future work is. We wanted to move to the cities also.
And with regards to the crime rate,
Sir?
with regards to the crime rate, so you went to like, uh, if I'm not mistaken, it is also it is at the granular level as well. That is
Yes, sir.
city and locality wise, the crime rates are given in the of the data set that is there.
Yes, sir. We have concluded, like suppose in Telangana we have all the cities. We have merged all them into a single state and we have used them into our data set.
So for both, you are working at a state level, right?
Sir.
Okay, okay. Yeah, good work.
Thank you, sir.
Thank you, Tanushree, for your presentation. Now I'd like to invite next presenter. Next, we have Varun Mittal, and he's going to present the paper titled State of the Art Artificial Intelligence Security Taxonomy. Varun, you may please proceed with your presentation.
Yeah, thanks, Harsh. Let me just go ahead and share my screen. Please let me know if you can see my screen.
Yes, it is visible.
Oh, yeah, great. So, yeah, good afternoon, everyone. My name is Varun, and I'll be presenting our paper on the state-of-the-art artificial intelligence security taxonomies, and I've worked alongside Dr. Madan Kumar Srinivas. And okay, let's get started. Um, so, um, So let's get into the AI revolution and its hidden peril. Okay, so AI is, undeniably revolutionizing industries from healthcare to finance, automating tasks and providing predictive insights. However, this rapid adoption introduces significant and often overlooked security challenges. As AI becomes more integral, its vulnerabilities can have far-reaching consequences. Some real world impact that we can think of this is we have seen adversarial attacks on autonomous vehicles, data breaches in AI healthcare systems, and the spread of misinformation via AI generated content like deepfakes. These aren't theoretical threats, they're actually happening now in the industry at a online personal level and at a very high level. So our contribution to this is that our paper addresses this urgent need by providing a comprehensive structured taxonomy of AI security issues, offering a framework to understand and mitigate these growing risks. Uh, so let's understand AI. So AI at its core stimulates human intelligence, learning from data, recognizing patterns, and making decisions using complex mathematical models and algorithms. As depicted in the figure on the slide, uh, AI systems operate through a layered architecture, which we have uh, created through our own understanding and evaluation of multiple architectures. So the blue layer we have is the data layer, where vast amounts of information is ingested and processed through like data collection, cleaning, feature engineering, etc. Then the green layer is the model layer, which is taking the brains of an AI system, the most important layer, which involves the selection of the model, optimization of the model through techniques like testing, training, model tuning, model validation. And then we have the deployment layer, which is the red layer, which is the final stage where optimized predictions or decisions are produced and integrated into real world systems. So the security implications involved with AI systems is that crucially, security risks are present at every single layer, the blue layer, the green layer, and the red layer. These make AI systems susceptible to data manipulation, model exploitation, and deployment threats throughout their entire life cycle. Let's move into our AI taxonomy, a layered architecture. So, to systematically analyze these threats, we have categorized the current AI security challenges into 8 state of the art taxonomies labeled T1 through T8, grouped under 4 main categories. We have the general security issues, which covers just basic data security and privacy. which you would experience through multiple models. And we have integration into physical systems because an AI model at its own is an independent model. And in real world examples, we have it integrated into physical systems like autonomous vehicles and etc. Then we have architecture and technical group, which we'll go further into in the next slides. And then we have governance and process related, which dives into the ethical compliance and governance issues. And finally, we have the security concerns in generative AI and LLMs. So our value proposition is that this structured framework provides a clear lens for organizations and researchers to identify, understand, and develop targeted mitigation strategies for diverse AI security risks. So let's get into model security and adversarial attacks. This is basically T3 from the structured taxonomy in our paper. And this area is all about protecting the brain of the AI system itself, which is the model. First, we have, so the diagram on the left helps you subcategorize model security into different attacks, which an AI system is uh, vulnerable to. So we have model protection, which is in the green box on the left side. This focuses on safeguarding the AI model from unauthorized access, intellectual property theft, and integrity compromises. Think of it as the foundational security for your trained model. This involves two key aspects. We have model confidentiality, ensuring proprietary algorithms and insights aren't stolen, often through encryption and strict access control like PLP. And then we have model integrity, which means preventing unauthorized modifications or tampering that could lead to inaccurate or biased predictions. Robust training data procedures and continuous monitoring are vital here as well. And then we have adversarial robustness, which is the green box on the right. And beyond basic protection, AI models, especially in high stakes applications like healthcare and autonomous systems, are prime targets for adversarial attacks. This is where our focus on adversarial robustness comes in. As you can see in the figure, we have categorized these attacks based on the attacker's knowledge level of the model. So we have two main categories. We have the black box attacks and the white box attacks. The black box attacks basically infers to no internal knowledge of the model. On one side of the black box attacks, we have uh, that the attackers have no knowledge. So we have evasion attacks and model inversion attacks, where the goal is to trick the AI system into misclassifying an input. For example, adding imperceptible noise to an image to fool a facial recognition system into thinking that a known person is a stranger, or vice versa. So identity thefts, etc., are all examples. And then model inversion is basically where this is more insidious. Attackers try to extract sensitive information about the training data by repeatedly querying the model. Imagine querying an AI medical diagnostic model, and based on its responses, you're able to reconstruct images or details of the patients it was trained on. And then we have the white box attacks where you have the full model knowledge. And this again is categorized into two main attacks. You have the data poisoning attacks, and then you have the backdoor DNN attacks. Sorry for the spelling of the backdoor. Uh, the poisoning attacks, in short, falls into the category where the attacker injects manipulated or deceptive data directly into the training set to corrupt the resulting model. A classic example is Microsoft's Stay chatbot, which was poisoned by malicious user interactions, leading it to generate inappropriate responses
Varun,
and
sorry to
ultimately.
interrupt you, but you have last 2 minutes. Can you conclude?
Yeah, sure. Yeah. And then backdoor DNS attacks, this involves injecting hidden vulnerabilities during the trading phase. And it basically triggers backdoor activities leading to malicious outcomes. So moving on into generative AI and LLMs. Uh, so this is basically now the new frontier of data generation in the forms of text, images, audio, and video. So models like GPT-4, Dolly, and others have revolutionized how content is made. So some security issues that we can basically dive into for generative AI and LLMs is data leakage. And this basically includes inadvertent exposure of sensitive training data, Then you have misinformation and deepfakes, as covered before, creation of false content, impersonating other people. Then model inversion attacks, again, we covered during model security, inferring data and replicating model via queries, injected queries, and then prompt injection, which means manipulating outputs through cleverly crafted inputs, which bypasses the security systems of these LLMs. And uh, some mitigation strategies, again, continuous monitoring of the systems, adversarial training, and input validation would be a good start. And the paper covers other in-depth methods. And just to conclude, that towards a secure and responsible AI future, our paper systematically characterizes these security challenges across the AI lifecycle, from data and model integrity to deployment and ethical governance. We also highlighted the critical importance of understanding and addressing threats like adversarial attacks and the emerging risks of generative AI and LLM. Moving on to a more holistic approach, the future of AI depends on a proactive, holistic approach that combines robust technical safeguards with clear ethical guidelines. It requires fostering collaboration between policymakers, developers, and industry leaders. And finally, our call to action by aligning with global standards and regulations as covered in the ethical section of our paper, like GDPR, HIPAA, and the EU AI Act. You can strike a crucial balance between innovation and security, ensuring AI's transformative potential is really safely and fairly responsible for all benefits, as we know that AI is increasingly taking over multiple actions and tasks around the world. Thank you.
Yeah, good work. You have covered the entire spectrum of this. So, yeah, good work.
Thank you. Thank you so much.
Okay. Okay, so moving for the next presenter. Next we have Siddharaj, and he will going to present the paper Target Recognition using Synthetic Aperture Radar Imagery.
Okay.
Siddharaj, you may
Hello.
please proceed.
Good afternoon. My name is Diraj. I will be presenting the paper. I will just share my screen. Can you see the screen?
Yes, we can.
Okay. Good afternoon. My name is Diraj Dhegaskar. I am an EC graduate from PS University. And today I will be talking about my paper, Target Recognition using SR Imagery. So the problem statement that we had was optimizing automatic target recognition in SR images for military vehicles aiming to enhance detection accuracy and efficiency in operations. So let me give an introduction. So SAR stands for synthetic aperture radar, which is a type of imagery that uses microwaves instead of using the visible wavelength to capture images. This is mainly done because we are able to capture features that are not visible in the optical wavelength, and also this helps us to mitigate weather conditions like smog, fog, clouds, etc. So the methodology that we had for this project was we first had a data set called the MSAR data set. This was a data set curated by the American Air Force, which consists of various military vehicles, which were all captured in SAR using SAR imagery. And we split the data set into a training data set and a testing data set. For increasing the training dataset size, we use a GAN to increase the dataset size, and then we did image pre-processing to capture the features from the vehicles so that we could better train our CNN model, and which would help us to in turn get better detection accuracy. So for the image processing, we first applied a leaf filter to the image, which helped us to reduce the speckle noise. And then we further reduced the noise by denoising the image. When we denoised the image, we lost a bit of features. So to bring those features back up, we sharpened the image. And as you can see here, um, the image has now the features yet less noise. So, and also we used a GAN, which is a generative adversarial network. It is a deep learning model which has two competing neural networks, mainly the discriminator and the generator. The generator generates the SAR images, and the discriminator discriminates between the real image and the synthetic data that we generate. For the JN specifically, we used a spectral normalization JN, which is basically we applied a spectral normalization to the weight matrix, which helped us to train the model better and also get better results for the generator. Through this, we were able to achieve a learning rate which was uniform for both the generator and the discriminator, and this helped us to generate high quality images that we could use in the data set. So as you can see here, as we went on increasing the epochs, the quality of the images kept getting better, and we reached a point where we could use these images as an actual data set to increase the accuracy of the model. So this was the SSIM, which is the structural similarity index measure, and this shows that the images that we had generated were in terms of the pixel values were close to the real SAR image. For the CNN model, we used a pre-trained model called the VGG19, which was then augmented by us. We added a layer which we added two layers, which was mainly the rescaling and the random flip. The random flip layer would randomly flip the images on the vertical axis, which would allow us to create some sort of randomness, which would help the CNN model learn better. Through this, we were able to classify the images in the data set and create a confusion matrix. As you can see in the confusion matrix, the true values and the predicted values are in line with what our prediction accuracy is. And for the prediction accuracy, before we implemented the synthetic data, it was around 96.7%. And when we increased the data set size, with the JN, we got the accuracy to be 98.1%, which was a substantial increase with the data set size that we had. And in conclusion, we first took a data set. We split it into two parts, which was the training and the testing data set. We applied pre-processing to the image, which helped us to bring out certain features. And then we used a JN to increase the data set size itself, which helped us to better train the model. And this helped us to get better classification accuracy. Thank you.
Yeah, once again, good work. So the MSTAR data set, it contains how many images?
So we had 1,000. We had 10,000 images in the data set, and once we were able to use the JN to generate more images, we had a total data set size of 15,000 images.
Okay, okay. And there's only one class. So this data set contains only military tanks or any other
It
equipment as
only
well?
contains military tanks, but those we have different types of military tanks. We have 10 classes of military tanks.
Okay, so this was a 10 class multi-class classification,
Yes,
right?
multi-class classification.
Okay, and in the BGG19, you have added what layers exactly?
We had added the rescaling and random flip layer.
So, did you check the accuracy without adding this and any other models that you have used to check?
So
My question is, why did you come for BGG19? So there
because
are other models as well, which are, I guess, which are more complex and which might give you better results.
Okay, so we picked this certain model because it had already had been trained before on image classification. So we realized that since our problem statement was image classification, we took a model which had been trained on images, and then we used the pre-trained image model and then molded the layers to help better fit our use case.
Okay. Okay. Good work. Good.
Okay,
All
thank
right.
you.
Okay. Thank you, Siddharth, for this wonderful presentation.
Thank you.
Now, just one quick announcement for the paper title, uh, book recommendation platform. from the author of Nikhil Wag. Is there anyone who is going to present the paper on behalf of him? Any co-author of that paper? Okay, so I assume there is no one for the from the paper. Okay, so now we have completed all the presentations of this session. I would like to thank you all for their wonderful presentations and this contribution in the session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of conference. We will be happy to have you all in the 11th version in 2026 in Goa. Further, all the presenter would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the printer. The publication will be live within 7 to 8 months. So kindly cooperate with the team of ICT4SD 2025. I also thank our session chair, Dr. Tatwadarshi, for chairing the session. Sir, there is a one token of appreciation to be the chair on behalf of Global Knowledge Research Foundation. So this is the one token of appreciation.
Yeah, thank you. Thank you so much. Thank you.
Thank you, sir, once again for your valuable presence over here. Now, before end of this session, I would like to request all of you to turn on your camera so we can capture the good memories of this virtual conference. I request all of you, if it is possible, you may please turn on your camera. Okay. Thank you, everyone. Thank you, sir, once again.
Yeah, thank you. And congratulations to all the participants. All the papers are very well written. So, yeah, continue the good work, everyone.
Thank you, sir.
Thank you, sir.